And welcome back, everybody. In this video, we're just going to take a look at some distributions of data, real life data, and I want to show you a really cool tool I learned about last year. I did this, my Math 1 class did this project, and I took this course, I think it was through NC State, and we used a really cool tool called CodeApp. And I've linked this CodeApp into our Canvas page. And it's right here. And if you follow this link, it takes you to a really powerful statistical tool. And you can upload data sets in there and everything. If you get interested in working with some of that stuff, let me know. And I'll show you how it has to be formatted a certain way. But anyway, I've already opened one. And I wanted to show you some data sets. They're big data sets too. This thing can calculate some pretty big stuff. So if you open up your CodeApp, you would open up one. You would start you a new file. And I've got one here, and I was messing around earlier, and I was just looking for things that we could look at together, and I found that if you go to their map, and I've zoomed way in. Now it doesn't want to work. There it goes. Wow. Okay. I zoomed way in, and what this map is a map of weather stations and data that's been recorded. Let me zoom out some so you can see what I'm talking about. It should be a whole bunch of data points on here. And you can kind of see how it populates these things. And over here, there's a list of weather stations. And here's the weather stations they've got listed. There's actually, I think, over 2,000 of them. When you first go in here, you'll see them all over the country. And there's just different things they've measured at these weather stations. If you start looking at this, now this is a data set. The whole thing together is one gigantic data set. So these are the entries. When it says index, it's the number of individual data points. And then these are called attributes. Things that an attribute describes what that string of data means. Like for example, elevation would tell me how far above sea level, and their unit of elevation is in meters. And if you can see what they've got here, they've recorded it for everything they did. The one I zoomed in on earlier was Newport Morehead City. That was about as close as I could find to us, and I think I highlighted it. And it popped up over here and showed me. Now somehow I think I've got some kind of lag going on with my internet out here, but it showed me this one. It would pop up and show you, so you can kind of see what it is. And it says it's 9.1 meters above sea level. And if you want to see some other things about what else is listed here, they've got years of data recorded. It looks like 2009 to 2020. It tells you the latitude, longitude. It seems like it gives some stuff about rain too. I can't hardly get over there to it, but or that's just tell me where the station is. Let me show you something else you can do with this tool. If you go over here to graph, this is what I really wanted to show you. You can literally drag an attribute and put it on the axis you want. Now this is really cool. Like if you wanted to say, well, let's take a look at all these elevations as just data points and see what they look like as a data distribution, kind of like we saw our bar graph earlier. And you just drag it to the x-axis. And there's going to be a lot. It takes it a minute here because there's so many data points. All right, so it tells me, I mean, there's literally, I'm wrong. There's like 3,500 data points inside this right now. If we expand it out and we can get a bigger picture of this, you'll start seeing a lot of data points in the lower elevation levels, because you got to remember, this is a graph of data points of elevation. That's all this is. And if you wanted to see some other stats about this, you can come over here to the measuring and say, well, what is the mean? What's the average elevation of a weather station? Now remember, this is in meters, so 899 meters above sea level. So it shows me that. And it says, hey, let's take a look at the standard deviation. Now, This is something we're going to be looking at in the next video. This is showing us that, well, hey, man, this is 959 units, so that's what the standard deviation is. But they go one direction to the right, then one to the left. Now notice this thing is really just built up on the left side here. But again, that's sea level. There's apparently a lot more weather stations around lower elevations. You get some of these high elevations. That's really high, isn't it? 3,500 meters. I mean, that'd be pretty high. Anyway, so that's a data set, a real life data set of weather stations all over the country. Now, there's another data set I've made that I wanted to show you on this video, and I really encourage you to get in here and mess with this tool. This is pretty fun to use. Another one I made was, this is a data set of 2019 Ford data. All right, so this is saying, hey, look, we got different things that are measuring here about Fords. Now, there's a lot of entries in here. We'll see how many in just a minute here, but there's a lot. They've recorded. They give them an air pollution score, city mile per gallon. They've got highway miles per gallon and things like that. So if you want to take a look at a distribution of, say, I don't know. Let's see, what would it look like, just to say what would the highway miles per gallon distribution look like of all the 2019 Fords that have been recorded. Okay, so there's my graph. And let's just drag it out a little bit larger so we can kind of see. And maybe we want to, well, we can just show a percent. No, it's barely hard to see because they're not talking. Well, how about a count then? That's a little easier to see then. Okay, so what we're looking at here, this is a frequency. If you counted the number of dots, which in terms, there's 18 different models with 24 miles to the gallon. And you can see up here the higher rates, there's not very many at all. 2 at 41, 2 at 40, 37. There's some really bad ones back here. But, so you're looking at a distribution. Now, this distribution is starting to look a little bit more symmetric than that really skewed one with elevation we saw a minute ago. So, and for some reason, it doesn't like these fractions or something in here. It won't calculate a mean and standard deviation for me. So, anyway, there's another distribution of data. And remember, these numbers now would represent a frequency. So a person could turn a frequency into a percentage of the data. Now, if you sum across the frequencies, that would give you the number of data entries, right? And things like that. So this is just us looking at real life data on this video. I encourage you to check out this CodeApp app. I may figure out an assignment for us to do with it. I'm not sure if we'll have time. Time's kind of running out. But you can use it for our stuff too as we progress along the statistics unit. So, all right, thanks for watching.